Okay guys, let's get started. If at any point of time if you can't hear me properly, please ping me in chat. That is on your GoToMeeting window. And any disturbances in presentation as well, please let me know. Okay. Hope you guys are able to see my screen and listen to my voice. Can someone acknowledge it? Okay, thank you. So today we will go through building loosely coupled systems or components. The reason I have taken this topic is to explain interfaces. In session 1 we had looked at abstraction, encapsulation, polymorphism and inheritance as well, and this is continuation to that part. And you many of you people might know interfaces well or might not well, and many of you guys I'm sure must be using interfaces in your day-to-day projects. But what you going to learn here is in-depth details of interfaces, how well you can utilize interfaces, what's the need of interface. So all these things you will learn from this session, and after this session you will be able to apply your own thought process in building loosely coupled systems or components using interfaces. Okay, coming to the main point, building loosely coupled systems or components is not simple topic. It's a very huge. I'll give a couple of examples. Many of you people are using e-commerce applications. Let us say Flipkart or Amazon or any other e-commerce systems. You see many components in that application. You will get SMS, you will get email, you will get order info, and you will get push notifications on your mobile. So these are all different components which are part of your single e-commerce application. So why I'm saying this one? What happens if your existing SMS component is not working? Let us say Amazon is using Airtel to send SMS notifications to the users. What happens if that goes down? What happens if email system goes down? Can you replace that immediately without affecting your end users? Can you replace SMS component without affecting the uh, uh, end users visibility? All these things are very important to successful application. If you cannot make your application up and running 24/7, then you are gone. All your business will go down. So that's the importance of building loosely coupled systems. We will see what is that. For new joinees, for new members, my name is Poona. I'm an architect having 13 years of experience. I worked on both private cloud and public cloud implementations and product development and application development as well. Let's get on to slide. So in this session, first our objective is mastering our code and crack your interviews. Okay, so this is my motto across all my sessions. So once you finish a topic from this session, then you should be able to master your code in that topic, and you crack interview uh, any question that comes on that topic. Let us say today I'm explaining interfaces. If you go to any interview, I'm sure you will crack that question, anything around your interfaces. That's my motto. Next one is tightly coupled systems or components. I will show one example here, very simple example, tightly coupled or systems components. And then I will explain interfaces and its characteristics. After that, I will show you a loosely coupled application, and it's not a different application. In point one, in point two, I take basically tightly coupled systems, one application. I will transform that application to a loosely coupled application in this session, so that you will understand what is a tightly coupled and what is a loosely coupled, and how we are transforming from tightly coupled to loosely coupled, and going to the next session. Tightly coupled systems. If you see, I have only 4 points here around tightly coupled systems. The reason, whoever attended the first session might have remembered all the characteristics of object-oriented programming. The first one is reusability, extensibility, inherit, maintainability, and simplicity. If you do not have all these 4 characteristics in any one of your application, that means that application is not successful. Okay, guys, some of you are talking. Please, can you mute your audio? Okay, the first point. In tightly coupled systems, if you make a modification in one component, it will definitely affect the component that consuming the first component. That means uh, you may need to redeploy the application. That means maintainability issue. Just imagine when you make any code change to your application, you need to unit test it, and you need to give it to the testing team, and then you need to do some process oriented tasks, and then you need to deploy it. These many things are involved. That means you are spending days and days of time for making a simple change, and it is cost effective, it is cost to the client. And if you make a change in one component, you need to make change to the other component as well. So you have a cost issues, you have a maintainability issues as well, because developers keep coming in and going out. Nobody knows the entire applications. Next thing, we basically tend to write code in individual classes, and mostly we do not make it reusable. And if you make a change in one class, and you do not know where to go and change the respective code, that's another problem. So you have a reusability issue. And also, cannot replace existing component. Let us say you have one component in use, but if it is not working, or if you need to replace it with the latest version of a library or component, then you cannot do it in tightly coupled systems. And that means you have a extensibility issue, because in tightly coupled systems, if you need to replace it, you need to go and remove the reference, and you need to update objects creations in your classes, and you need to do many more as well. So that's the extensibility issue. So because of all the above three issues, you have the simplicity issue, because your application are simple to make changes to your application, to make your application extensible, to make your application maintenance easier. So tightly coupled systems are not adhering to the object-oriented programming principles. Now we go and make changes to the tightly coupled systems and make it loosely coupled system, and make it adhere to all 4 principles of object-oriented programming. Then we are successful. I'm moving on to the next slide. As I told you, all my examples will be simple. I mostly focus on the implementation of object-oriented principles in this session, not on a logic. Okay. So in the first part, if you see here, you have 2 diagrams in this slide. The first diagram contains 2 components. The first component is external component 1, and the second component beneath that is tightly component systems lab. Here, the tightly coupled systems lab is a user interface, and external component one is a class library. You can think of it as a class library developed by one of your team members, developed by other team in your project, or downloaded from your NuGet package or somewhere else. Okay, what I have done here, I have directly referenced the DLL of external component 1 in my user interface tightly coupled systems lab. And in the second component, in the second diagram, what you see is another component, that is external component 2. So in this sample, I am using two external components. They are external component 1 and external component 2. And these are being called in my user interface. Okay, if I have to add another component, then I have to give reference to my class user interface and create objects, and then build, redeploy. If I want to replace external components, then I have to delete them and add new one. So all these lead to additional work. You need to make code changes, redeploy, test, and then to staging, and then to production. Waste of dollars here. Okay, before going to interfaces, I'll just show you the code. Okay, so this is my application. As I told you, tightly coupled systems lab is my user interface. For simplicity, I have not taken web application or a WCF application or WPF application. I have taken Windows form for simplicity. So I just have a form that contains a button control. So what I'm trying to do here is to call a method in my external component, and everybody knows how we do. We refer, we add a reference to that external component DLL in our user interface. So you will basically add a reference here and then go to your button click event, and then you will basically use using keyword to add a reference here, and then you basically create an object of that class. This is how we do. Very simple, isn't it? Many people argue that it is very simple to code. Why you want to make it complex by writing additional code? Uh, Please be remember that its simplicity doesn't mean the simplicity to the developer, simplicity to the business. When you make it simple to the business, then business can make money. But when you make it simple to the developer, then business can incur into losses. End of the day, we are earning money based on the business. So you need to support the business. Make things simple to the business. Make your application scalable, extensible, so that business doesn't need to incur in rework. And then they can save money and they can share the money with us as well. So just so what my if you see, I have a simple class that is Airtel SMS connector. I created an object of Airtel SMS connector, and just showing that output in a message box. This is from external component 1 library. Let us see that. So this is the external component 1 library developed by your one of your team members or a different team. So what I have here, I have a simple class here that contains one method, that is execute external component method. I'm not doing any logic here. I have simply returned a message, that is message has been successfully sent. Message has been sent successfully from Airtel SMS customer. So let us see now. Let's click this. So I basically invoked a method from external component one library. So that method returns the message. Message has been sent successfully from Airtel SMS connector. Very good. It's very simple. Now, now let us say that my Airtel SMS connector or my Airtel provider went down because of some hardware issues from or because of some unexpected conditions or power failure, anything. But I want my application to send SMSs still. So basically, in tightly coupled components, what will happen? You basically take uh, another SMS provider. Let us say that is external component 2, which is having a Vodafone connector. So I have a simple class here, Vodafone SMS connector, where I have a method called send SMS. You please remember I have the method name here, send SMS, and in Airtel SMS connector class I have the method name as execute external component method. Please remember these two method names. Okay, now what happens? My Airtel provider went down. Now I need to use the Vodafone SMS gateway. Is that such simple? No, because you need to change your code. You need to test it, and then you need to deploy it to the staging and then to the production. Many things are there, and you cannot wait for SMS for days and days, right? Imagine if you wait for SMS, let us say OTP, for you don't even wait for 10 seconds or even 5 seconds, you will get frustrated. Then how can we assume a customer can wait for 3 or 4 days to get SMS notifications from an application? Nobody can wait. That means you lose the business. Obviously, customer will go to some other e-commerce application. Now, as I told you, what we do, we basically come to our user interface, give a reference to another component, that is external component 2, which contains Vodafone SMS customer, and then you basically come here. For the simplicity, I have already written code because it takes a lot time to type and execute. So now what I have done here, Vodafone SMS customer, I created an object and then I am trying to execute a method. Oops. I have a build error here. So what's that here? Let us see. It is saying Vodafone SMS customer doesn't contain a method execute external component method. I told you a couple of minutes ago, remember the method names. In component 1, I named my method as execute external component method, and in the same lines, when I'm using my Airtel SMS customer, I tend to use the same method name thinking that both are SMS connectors, both might be having the same method name, which is not actually true. Again, this is a confusion. Developers ask for a KT or documentation. Again, you spend days and days. So even though the functionality of both the components are same, that is sending SMS, but both are having different method names. Okay, let me see what is that method name that is in Vodafone SMS customer, which is in component 2. Here the method name is send SMS. Let me come here and send SMS. So now that is fine. Let's execute. Cool. Now I'm able to send a message using Vodafone SMS customer. Message has been sent successfully from Vodafone SMS customer. This is the output. Okay. Now what happened basically? We spent almost 15 minutes in this lab, 5 minutes in this lab itself, knowing the components and their classes and their methods. In real time, it takes days and days, minimum 1 week to send one change to the production. uh, no customer will wait for 1 week to receive an OTP or one-time password for your banking transactions, or no customer will wait for 1 week to send order confirmation on your mobile to receive. So, so these are the issues in tightly coupled systems. Now we will see how we will make it loosely coupled component. That means we can inject, we can induce different components at runtime without redeploying your application, without sending it to your testing team for testing, without making any changes to your user interface code. Remember, I am not going to any utilities or online libraries or online tools to do this one. I am purely using your base classes, .NET built-in libraries to do this lab. Okay, let me minimize this. Hope you understand the tightly coupled components systems issues. Let's go back to interfaces. Guys, I know many of you are experienced and you know about interfaces, but please be patient. And again, you can think of it as a revision about interface characteristics and what is an interface, etc. And then we can get into the coding. So what's an interface? In a nutshell, interfaces, the first point, if you see, it plays a vital role in creating loosely coupled systems or components or classes. Remember, if someone says, hey, let's make these components loosely coupled, you should think of interfaces. Why? We will see. So coming to the definition, interface is also a class. If you see, whenever you create interface, it is .cs extension. But a interface doesn't have any implementation. That means any methods or properties in your class will not have any definition, will not have any logic. It is just a prototype. So what you can have in interface, you can have events, indexes, methods, and properties. These things you can define in interfaces. And interfaces should be inherited by your classes or structures, and whatever is the class that is implementing the interface must provide a definition or logic to the method defined in the interface. So this is a nutshell about interface definition. So you need to know some key notes. Many of you know about it, but think of it as a revision. For you who don't know, just remember. So you will use interface key, and all the methods or properties that you define interfaces by default public. You cannot give any access modifier, let us say private or protect or internal to the object, to the types in your interface. A class can implement multiple interfaces. As I told you, classes must implement all the methods or properties or indexes that are defined in the interface. You cannot define a variable in interface that is like a string or integer. You cannot have such type. And you cannot have method definitions or properties definitions in interfaces. These are the keynotes. Please remember these things. Anyways, we will see in action or in the next slide. Okay, now, okay, let's have some session. I'm just going to create one interface, just so that you will remember what's an interface and their properties. So I will say public so you see, actually I have a resharper on my system. That's why even though I given private, resharper deleted actually. Still, I will override that. See, I have got an error. Private doesn't exist in the current context. Or let's make it private. The modifier private is not valid for this term. That means you cannot give access modifiers in interface. Let's remove this one and then build it. See, now the build is succeeded. That means you cannot have access modifiers in interfaces. By default, all the members in an interface are public. Now I'm trying to give some definition. Will it work? No. If you see the error, interface members cannot have a definition. That means we just seen that one. Let's remove this one. Build it. Sorry. Build is successful. Likewise, please practice these things so that you will not struggle in your interviews. It takes hardly 5-6 minutes to practice these keynotes. Without spending much time on interface attributes or characteristics, I'm going to the loosely coupled component. Okay, we've seen 4 issues in tightly coupled systems. That is reusability, extensibility, maintainability, and simplicity. We are addressing those concerns in this loosely coupled systems example. What we are going to see is I will make modifications in one component, still my user interface will not be affected. I will make I will interchange my components at runtime. Still, I do not need to redeploy my user interface. I do not need to test it. I can uh, I can simply plug and play. I can simply update my replace my components at runtime without making any changes to my user interface code. By doing all these things, I am making my application very simple. So I'll just read out these things. Modifications in one component will not affect the consuming component. That means consuming component here is user interface. Ease of plug and play, that means reusability, can replace existing outdated components or old components by using the latest components. We don't make any code changes. Because of all these things, we can say our application is very simple, which is a property of object-oriented programming. Let us look at the diagram here. So in tightly coupled systems, just revise that one. What you have here is The user interface, which is a tightly coupled system slab, is directly referring to the components. I mean, you have a reference in your user interface application, that is external component 1 and external component 2. You are referring to the components directly. Whereas in loosely coupled systems, no component is linked together. You see, external component 1, loosely coupled system slab, and external component 2. As we seen, external component 1 contains Airtel SMS customer connector, Airtel SMS connector, and external component 2 contains Vodafone SMS connector. And loosely coupled system slab is an user interface. All these three are not connected. You see the arrows here. All these three are communicating to each other via interfaces. So by looking at this diagram, anyone can think I can connect any component at runtime without making any modifications to my user interface, because my user interface is not directly referring to the external components. So just remember or make a picture of this in your mind. Let's get into code. Please give me a couple of seconds while it is opening. Okay. That's great. I got my application open. Okay. You see here, in tightly coupled systems lab, I have three projects, two class libraries, one UI, that is Windows Forms. In loosely coupled systems lab, I have another project added here, that is interfaces. So all I am doing here is to send SMS from a component. In external component 1, I have Airtel SMS connector. In external component 2, I have a Vodafone SMS connector. So basically, you can think of it as my wrappers around SMS, Airtel or Vodafone. Basically, they give us some libraries. We need to use them. Okay. Let's look at interfaces. Uh, Interfaces project. I have two interfaces here. The first interface is iExternal component. So my iExternal component contains a method called, that is execute external component method. Remember, this is execute external component method. This is my first interface. And the second interface, this is I inject external component. I have a method here, that is inject external component, and the parameter is the first interface. I'm sending the first interface as a parameter to the method in this I inject external component. You will see why I have this I inject external component. Okay, so I'll just show you one code map here. Thanks to Visual Studio for giving me rich interfaces to showcase my code. Earlier I used to write all these things in UML. Now I do not need to create UML diagrams. So I just want to show you the calling and caller methods. Guys, if you see, loosely coupled systems lab is my Windows Forms application, which is nothing but my user interface, and that contains a class called program, which is basically entry point. Whenever you execute, this program class will get executed. And then I have my user interface, that is form one, which is the form. You see the button on that one, and form one is calling a class called our component class. So the reason I named it as our component class, uh, I am going to inject, I'm going to invoke my external components from my our component class. Guys, many people have the habit of writing logical statements in your user interface. That's not good. Okay, that's the reason I moved all my method invocations to my our component one class. And after that, if you see, I have this iExternal component class, which is basically contains a method called execute external component. This is a method which basically sends SMS to the users. And actually, the send SMS logic is available in your external components, that is external system 1, external system 2. So this external system 1 and external system 2 are implementing iExternal component. Please understand why I'm using an interface here, iExternal component, and I'm implementing this external component interface in external system 1 class and external system 2. A couple of minutes ago, we seen Airtel customer class and then, sorry, Airtel SMS class and Vodafone SMS class. Both are sending the SMS, but both are having different method names. One is send SMS, the other one is external component, execute external component method. If you remember from session 1, uh, uh, we looked at simplicity and maintainability, all these things. Here we have an issue of maintainability. Different components serves the same purpose, but we have different method names, which is not good in terms of maintenance, because you need to remember, you need to make changes to your user interface, etc., etc. One of the beauty of interface is, or one of the use case of your interface is to enforce naming standards across all your classes. So what I'm doing here in my interface, I have a method called using execute external component method. So any class that implements this interface must provide an implementation this execute external component method. You see, now all the classes will have the same method name to send SMS. Whereas earlier, when there was no interface, different classes or different components are having different naming conventions. This makes it simple. This makes it your maintenance easier. So that's one of the use cases. Just remember, interfaces will be used to enforce naming conventions across all your classes. This is very important point. And I inject external component, which is another interface. You see, I have a method here, inject external component, which takes a parameter of iExternal component interface type. Okay. This is how I architected my loosely coupled system. This is basically transformation of your tightly coupled system to loosely coupled system. By using this structure, I can remove external component system 1 at runtime and inject external system 2 at runtime. I do not make any changes. I do not make any changes to my form 1 logic. What contains that form 1? Let's look at now code. Okay, now you see, as you remember, both these components are implementing the interface iExternal component. So that's the reason you can see a reference here, interfaces, and you also see a reference here, interfaces. Let's collapse this and let's open Airtel SMS customer. I have implemented iExternal component interface, which is available in interfaces method. Since I implemented, I have to implement this method, execute external component method. In the same line, in Vodafone SMS customer as well, I implemented the interface iExternal component and then the same method name. See, I have enforced the naming convention rule on my components, on my classes, which is making it simpler. And then you remember this I inject external component. This basically holds a reference to your iExternal component. This iExternal component is implemented by the external component classes. That's the hierarchy. That's the relationship. Now let's come to form 1. Form 1, it simply contains a button which executes the method, execute external method of your external components. Guys, give me a second. Cool. I'm back. So let's go back to tightly coupled systems. In tightly coupled systems, we've seen form 1. If I have to use Airtel SMS customer, I have to create an object of Airtel SMS customer and then invoke the method. If I have to use the method from Vodafone SMS customer, SMS connection, then I have to create an object of this Vodafone SMS connector class and then use the method send SMS. That means I have code changes. I need to do the redeployment. When I go to loosely coupled systems lab, I do not make any such changes. I can simply interchange, or I can simply use different components, SMS components at runtime without making any changes. Just see that now here. Uh, uh, Guys, please remember here I have two examples here. Uh, one on classes, one on DLLs. Classes means uh, you basically create objects of your classes in your consuming classes or consuming user interface. DLL means you will refer the DLL and then use the class in the DLL. In both of the cases, you need to uh, create the objects of your classes. In this example, I'm not going to make any changes as I told. Okay, button 1 is my event. On click of button, I'm basically sending SMS. So I am showing first example 2 and then I will go to the example 1. So what I am using here, you see, I have a couple of statements here. I created I an a variable of I external component. The name is external component dependency, and I'm getting I am retrieving the some class reference to this interface from a method, that is get desired dependent external component. This is very critical one. Get desired dependent external component basically injects your Airtel SMS connector, Vodafone SMS connector at runtime. You do not make any changes to your code. Here I will drive everything by app config changes. Okay, so I got the reference to my class through my interface. And then next one is, you see, our component class. I created an object of our component class, and basically our component class, if you see, if you remember the diagram, it is basically implementing I inject external component. You see, I inject external component. Let us see in the references. So our component class, if you see here, implements I inject external component. Let's go back. So I'll go and show this one as well. F12. See here, our component class implements I inject external component interface. I inject external component interface is basically having a method I inject external component which takes parameter as I external component interface. This I external component interface is being implemented by your Airtel SMS connector and Vodafone SMS connector. So I am injecting my I external component via I inject external component to my main class. Our component class contains a method called invoke external component method, which basically calls your external components. Now let's see here. So our component class is being instantiated, and means an object is created, uh, and from that object, our components object, I'm calling the method inject external component. When I call this inject external component, it basically calls I external component interface. Probably might have got confused. Let's go back. When I instantiate our component class, it will have a reference to I external component interface, which was implemented by your external classes. They are Airtel SMS connector and Airtel Vodafone SMS connector. And then the simple thing, that is invoke external component. That means you will see a message box. Now let's see in action. Basically, let's start it, and then guys, now I have sent SMS from Vodafone SMS connector. You see here, message has been sent successfully from Vodafone SMS connector. Before going and explaining the rest of the code, I'm going to replace this Vodafone SMS connector using Airtel SMS connector without making any changes to my code. That means we are solving this problem, extensibility and reusability issues that we seen in tightly coupled systems. Just close this. You remember this message? Message has been sent successfully from Vodafone SMS connector. If you guys do not believe in me, I'll just show you. External component 2. this is message has been sent successfully from Vodafone SMS customer, and then Airtel SMS connector. The method name is again execute external component method, and the message what we see in is message has been sent successfully from Airtel SMS connector. Guys, I did not make any changes to my user interface, uh, but I'm going to send SMS from a different system. Now see, before we go in action, just remember message has been sent successfully from Vodafone SMS connector. Just close this, close this. Now I have my app config. I'm going to make changes only to the app config. So right now my app config contains two keys, that is a class name and then DLL. Class name is fully qualified name of my Vodafone SMS connector class. You see external component 2 dot Vodafone SMS connector, and DLL is the path to the DLL external component 2. I placed my DLL in blah 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 in external assemblies in external component. What I'm going to do, simply I'm going to comment these two, and then I'm going to uncomment. So here I'm using Airtel SMS connector. Earlier I'm using Vodafone SMS connector. That's it. I'm going to execute it. Now you see, message has been sent successfully from Airtel SMS connector. See, I did not make any change to my user interface, but still I'm able to switch uh, from Vodafone to Airtel to send SMS at runtime. This is the beauty of loosely coupled systems, but you need to architect and design it carefully. So how I have done this one, I would like to show one more thing as well. Look at the references section. References. Do you see? Do you see the libraries, external component 1 and external component 2? No, because I have not referenced here at all. I am loading the DLL at runtime, and I am loading the class at runtime based on my app config settings. My app config settings uh, contains a path to the DLL and class to be used. Let us see that in my. See, I have placed these DLLs in a folder, and my user interface basically loading the live DLL from this path. Now let us see how I have done that one. Guys, apart from interfaces, you are also going to see how I am loading DLL at runtime, how I am loading classes and their instances at runtime without having any physical references to your project, user interface project. As I told you earlier, I was explaining this thing like how I am getting reference to my Vodafone class or Airtel class without having any physical reference. Let's do F12. Guys, I am here using a concept called reflection. Some of you guys might have learned about dependency injection and inversion of controls. There are many utilities available like structure map, unity, and castle windsor, like that. Many more are there, but all these are evolved after 2007 or 8. Before that you do not have those libraries. I started my career before that, so we used to write all those dependency injections on our own. Of course they are not perfect in terms of garbage collection, but we used to write it. Now we have the libraries available. They made our life easier. But what happens if you do not know the internal mechanisms of any tool or library? You will not have clarity. Every time you learn let us say Microsoft has given Unity IOC container, and some other guy given Castle Windsor container, and some other guy given structure map. All these utilities will serve the same purpose, but every time you will your learning curve is same. You will spend the same more or same time in learning different components of the same purpose, which is of no use. That means you are not reusing your knowledge because you do not have the fundamentals. So the crux here is reflection. If you see how I am loading a library, I mean DLL at runtime, and how I am creating an instance of class in that DLL, that is via reflection. You see what I'm seeing, what I'm doing here. I have taken the path of the DLL that which was in a folder, and then I'm using a class called assembly, which is in system.reflection. I'm loading. I have a method called load from. I can load a DLL at runtime using assembly class into memory, and then I have loaded the DLL, but I do not know what's the class name to instantiate, and in order to use the method of SMS, send SMS, to send SMS. So the class name, I have taken the fully qualified class name again from app config. My fully qualified class name is the namespace dot class name. So that is external component one dot Airtel SMS customer, which is the class name. And then so now I got the DLL loaded, I got the class name. Now I need to make this class. It is just a name now, but we need to make it a type, class type. How I am going to make it a class type from just a string, a normal name? So I have a method called get type. Once I pass this class name to that get type method, I have already DLL loaded. This get type method will look into the DLL if it has got a class called Airtel custom Airtel SMS connector or Vodafone SMS connector. If it is having, if the DLL is having that class, it will create that type and will load that class into memory. That's what external component type. Now I have the class available, fully functional class available in memory, and the next thing is creating an object. How you will create an object? So you have a class called activator that contains a method called create instance. All I need to do is use this class and use this method create instance, send that class to this create instance method. That's it. You got the object of your class. After that, everybody knows. Use that object to execute the method. So what I have done at runtime, guys, can you please mute your guys, please mute. दिए ना तुम्हारे कंप्यूटर, अरे कंप्यूटर पे दिखता है ना हमको, अरे वो ठीक है, तुम प्लीज भाई लोग म्यूट करो आपका ऑडियो प्लीज. थैंक यू. Okay, so I loaded my DLL and sorry for the disturbance. Sumant, please mute your audio. Okay. I loaded my DLL. I taken my class from the DLL. Guys, please. Okay. So I loaded my DLL, I loaded my class and used the create instance method of activator and created an object. You see, The return type of my get desired dependent external component is iExternal component interface. So I got the iExternal component. So here this method returned iExternal component. Now this external component dependency is having an interface, fully functional interface. That interface is already been implemented by Airtel customer, Airtel SMS connector, or Vodafone SMS connector. Now in my app config, I have given Airtel. That means the iExternal component interface is now having a reference to my Airtel SMS connector. So I'm using my our component class, which basically implemented iInject external component. Now iInject external component is having external component interface reference. So here, likewise, I have two in a nutshell, if I have to say, I have used two interfaces. That is, one interface contains method to be invoked. The other interface contains the interface as a parameter. So I inject external component is having a method to have the reference of external component interface, which is implemented by Airtel and Vodafone SMS connectors. Okay, you remember that one. And after that, I so so I got the interface reference here at runtime and I executed this method. I'll just debug and I will show you. Okay, I clicked on the button. Now I'm going to the get desired dependent external component F11, and then you see, let's say F10. So now I have got the path of DLL that is in my external assemblies path. You see that one, external assembly slash external component one. And then if you see earlier that was just a path. Now you see the fully functional DLL. You see the version as well. External component 1, the version is 1.0.0.0 culture public key. That means it is fully functional DLL in memory. It is loaded into memory. And then I need to have the class. Just do F10. Now I got the class name, that is external component 1.airtel SMS connector. It is just a string. If you see, please see, it is just a string. Okay, and then now you see, now I have got the fully functional class. If you observe, that is an external component type. Class name is Airtel SMS connector. Full name is component 1.airtel SMS connector. Just expand it. You see all the properties are attributes of a class. That means it is fully functional class. Now do just F10. I got an object now. You see, this is the object. You got it. External component 1.airtel SMS connector. Just to F10, go back. Now you see, now this iExternal component is an interface, is having a reference to the class Airtel SMS connector. Now you see, now our component class is basically having a reference to Airtel SMS connector. That means from our component class, I can execute the method in Airtel SMS connector. Let's see, F12. Here if you see, what is external component here? External component 1. That means it will go to the external component 1 library and it will go to the Airtel SMS connector class and execute the method, execute external component method. After that, you will see message has been sent successfully from Airtel SMS connector. That's it. Now what I do is, now I will just switch and I will I will send SMS from the reason I am showing again this uh, sorry, the reason I am showing again this example so that you can remember it easily. Now I am going to send SMS from Vodafone SMS connector. All I have done is change to my app config. I will again debug F10, F11. You see, now I have the path of external component 2. Earlier I was having external component 1. Now I am having external component 2. And the class, earlier I was having a class name as Airtel SMS connector. Now I am having the class name as Vodafone SMS connector. It is changed. Now I have the fully functional class, that is external component 2 dot Vodafone SMS connector. Earlier I was having Airtel SMS connector. So now our main class is containing a reference to the external component 2 library and the Vodafone SMS connector. In previous, we have external component 1 and Airtel SMS connector, and that's it. Just now we see SMS has sent from Vodafone SMS connector. That's it. What we have done, we are able to switch SMS connectors at runtime without making any changes to our UI. You are just dropping a DLL into your assemblies library, and then you are making change to app config. Since it is a configuration file, you do not need to redeploy. So that's how you can utilize interfaces. The reason we use interfaces to build loosely coupled is interfaces can contain reference to any type. It basically have a reference to a class. That's the reason. So we can switch it at runtime. It is having a reference. It is not using the methods in the class. It is only having a reference to the class. Guys, coming back to my slide. Interface use cases. What we have done, it interfaces helps you to build decoupled applications or loosely coupled applications, or you can decouple the classes. That means in one class you are basically creating an object of another class. If you have to change that object, you need to again make code changes. But using interfaces, you do not need to do that one. Instead of creating an object of class in the UI, you have used interface to make a reference to the class. That's how you decoupled the classes. You decoupled user interface from the components or classes. And the second point is enforce uniformity. That means you have enforced naming conventions of method names across all your classes. Now all the method names are uniform across all the components or classes. Dynamic polymorphism, I just made it a placeholder so that you can recollect what we have done, how we have done dynamic polymorphism in this class. I explained you in previous class. Just go and fill this placeholder so that you can recollect your session 1 and you can recollect your dynamic polymorphism. Guys, that's the end of this building loosely coupled systems or components. This is at very basic level. I want to give you a feel of loosely coupled systems so that whenever you look at any applications, you will see how they implemented. You will understand how they implemented loosely coupling, and you will also see whether they have done tightly coupled or loosely coupled. If they have done tightly coupled, then you can tell your team leads or architects or anyone or your fellow colleagues, say that boss, this is not good. You cannot make changes at runtime. You cannot induce external components at runtime. You need to go for redeployment. You have to do all these things. Okay, and that's it. Next one, guys. Our next steps will be part 2. I will explain in detail about loosely coupled, because loosely coupled systems are like ocean. It is not just a SMS connector. You have the messaging components, you have email components, you have utilities from Amazon, Microsoft, and many more providers. Basically, we buy them. Like, you might have heard of service buses, you might have heard of message queues, you might have heard of inversion of control containers. All these things are examples of loosely coupled. In this session, I have used interfaces to explain you to build loosely coupled systems. And in next session, I will cover abstract classes, and we will also cover some replacing RDBMS and DBMS at runtime. There is a reason behind for not using abstract classes in this session. That's the end. Uh, you can contact me on my email, or you can ping me in WhatsApp. uh, I know you might not remember everything what you have seen in this session, but once I share this slide, code, and the audio recording, or in this video recording, you will be able to move forward and backward and understand it again. Uh, Thank you very much, all. That's the end of this session. As usual, I would like you guys to give me feedback so that I can improvise. And sometimes I may not go in detail because of time constraints, but will answer your questions personally as well. Thank you very much. That's the end of the session. We'll catch you in later sessions.